Hi, Talking in Life Math and History, and we are going to take a look at the different types of forces. So we've always been looking at the formula in the last episode, where F represents our force equals our mass times the acceleration of an object. However, we still kind of need to dig deeper on that, because when we say force, it still doesn't really understand what we're actually talking about. Because what if I told you that there are many different types of forces? When we just say force, then we're not very clear and we're not very clarifying what kind of force that we're talking about. So that's why we're going to learn 7 different forces with their symbols and an example and what their actual definition is. So the first is right over here. So when we hear the word applied force, what do you think of? Well, this is the most common kind of force, what people would usually think about, because we actually have to use it every day, every time. A, you exit your bedroom before you go to school, and B, you have to open the door to your physics classroom. So what is it? Yes, applied force is literally going to be called, or the actual definition is, force applied on an object, which is actually the literal definition. So what that is actually saying is you have an object right here and you want to move that. So what you do is you push it or you pull it. The formula or the symbol for applied force is actually going to be FAPP. So that is telling us force applied is going to equal your mass times the acceleration, for example. Applied force is easy to understand, and not only that, it's kind of easier said than done, or self-explanatory. So here is the second one, a gravitational force. And it's also very self-explanatory. Because if me and you live on Earth, which probably you do, if this video ever survives the next 100 years, a gravitational force is talking about your object, or you, is right here. And it's talking about the gravity, Earth's gravity pulling you down. Remember, the gravity is negative 9.8 meters per second squared, but that talks about how fast things are falling. What's really happening is the gravitational force is basically there's some kind of force pulling you down back on Earth. And the definition of that is actually saying your weight. And that is because gravity is acting upon something. So every time you measure yourself on a scale, that is basically your weight, because that is gravity pulling you down to get your weight. The formula for gravitational force is Fg or Fw, W representing weight. Many physicists or many physics teachers always try to avoid Fw because that could be mistakenly used as work. Because in physics, W is denoted as the letter W for work, which is another thing we'll learn for force. So that is a gravitational force. Next one here is normal force. And there's not really something called normal force because it's not normal. What it's trying to say is imagine you have an object right here on the ground. Once again, if it's on a flat surface, then that gravity is going to push it down. Okay, there's almost a normal force, but not only that, that box is also having the ideas of pushing it up because the structure of the box. However, if I tend to move that thing and turn it into a ramp right here, the box is going to want to slide. So the force of the box is going to go perpendicular to what the gravity is. So it's going to go that way and that way. And not only that, gravity is still going to push you down, but the box is going to move perpendicular that way. So that is a normal force example. Usually when something's trying to stand within itself, and also every time it happens, it's always a perpendicular force to the direction where it's headed. The formula for normal force is going to represent F of n or F of norm. Most physics teachers will want you to write F of norm because it's more clarified. So yeah.
Don't let him get through, man.
We've got company.
5, 4, 3, 2, 1.
Wait, Henry's still down there.
I'll keep the door open as long as I can.
Come on, we gotta go.
Next one we're going to take a look at is called the friction force. So when you think of friction, you think of two things rubbing together. And yes, that is correct. If you rub your hands together, it'll create heat. That is called friction. Because friction force is basically the force exerted by moving across a surface on a type of terrain. So, friction force can apply like cars can use friction force to make themselves go. And also, if you ride a sled down a hill, that's also using friction force because the sled is in contact with the ground. This doesn't really apply to hovercraft. It kind of does, but not as much as things that touch the ground. And it's going to be F of F. That is going to be your symbol for the friction force. The next thing we're going to take a look at after friction force is air resistance. So when you think of air resistance, yes, you are going to talk about things in the air. But what we're trying to actually say is it's a type of force when objects are in the air. Pushing air molecules and particles and molecules. So, air resistance is one of those things that we kind of ignored in physics in the last few lessons. When we talk about an object falling on the ground or an object going up and down a curve like that, we've been solving those for the speed, the time, and the distance, but we were ignoring the air resistance. Like we talked about a gravitational pull, everything falls at negative 9.8 meters per second squared. However, that is because those so-called scientists removed those air particles. But since there's air resistance, there's going to have a feather versus a bowling ball effect. The feather is going to land last because it will just float down to the ground. Like paper, the bowling ball is going to hit the ground very hard. There's a lot of aerodynamics in air resistance when something falls, or when planes fly through the sky. And when it comes to air resistance, your symbol is going to be F, force of air. So that's air resistance. After the air resistance, we're going to take a look at the tension force. And the tension force talks about string, how strong and how much force a string actually has, like a wrecking ball. The string has to be very powerful to hold that kind of weight to destroy buildings. And the actual definition is the amount of force exerted on a string, cable, or wire. So that is calculating the amount of force exerted on a string, cable, or wire. However, this does not talk about elastic bands or people like Elastigirl from The Incredibles. That is tension, but it doesn't count because that can stretch and heat the system. Your tension force formula is going to be F of T. That is going to be the tension force.
I got you.
The last thing we're going to take a look at is called the spring force. And this kind of force is also what cars have to do. Cars also have to stay smooth as silk when riding on rough terrain. And spring force is actually what helps them. So when we talk about spring force, we're going to say the force exerted on a spring, compressing and stretching. So cars have to use springs on their axles and their tires because they don't want the experience of driving to be rough and hard. Also, the springs also save the car from any kind of damage, financial insurance damage stuff. When you talk about spring force, your formula or your symbol is F of S, the force on a spring. So there's the spring force. You usually see them in the suspension of a car, and that explains all of the forces and that explains an introductory idea of all the forces, the different types of forces. I hope this video has helped you understand the different types of forces. Thank you for watching Topping Airlines Math Industry. Like and subscribe.